So on to problem number 6 of the MIT integration B qualifying example 18, which is indefinite integral of the cosine of x times the hyperbolic cosine of x plus sine of x times the hyperbolic sine of x or sinh of x. So this is kind of tricky, but still easy. So let's look at the two methods that I personally may use to solve it. So our problem is cosine of x, cosh, or the hyperbolic cosine of x, plus sine of x, and sinh or hyperbolic sine of x. Well, didn't need that second bracket. So let me divide this into two integral, the yellow and the blue. Yeah, okay, so we'll just have the white there and then the blue. Okay. Okay. So the yellow integral can be integrated as follows. So we have cosine of x, cosh of x is the same as cosine of x times the derivative of the hyperbolic sine of x, right? Which using integration by parts becomes cosine of x sinh of x minus the derivative cosine differentiated is negative sine of x and then sinh of x. So which is equals to cosine of x sinh of x plus sine of x sinh of x. Okay, so we have a problem that has come to that point. Sine of x times the derivative of cosh of x, which is plus, again using integration by parts, sine x cosh x minus cos x derivative of sine x times cosh x. Now we clearly see this is I with this I, so when you bring I here, 2I is equals to cos x sinh x plus sine x cosh x. Therefore I, which is the derivative of cosine x cosh x, is equals to a half, divide both side by 2 of cos x sinh x plus sin x sine x times sinh x plus the integration constant. Sorry, it's not sinh but cosh. So this is cosh of cosh x plus the integration constant. So that's the yellow integral. So we have cosine x, sine x, sinh x, sine x, cosh x. So let's see the blue integral, right? So the blue integral, which is the integral of sine x sinh x, which is equals to sine x times the derivative of cos x, and which can be using integration by parts. So we have cos x sine x cos x minus cos x cos x. Derivative of sine x is cosine x, and then we bring cos x, which is sine x cos x minus cosine x. The derivative of cos x is the derivative of sinh x, and this is sine x cos x cos x sinh x minus derivative of cos x is negative sine x sinh x. So which becomes sine x cos x minus cos x sinh x so there is this plus and then negative because we have 2, and then there is this negative, so it becomes I, because this is definitely I, and then we have I on this side. So essentially what we have is this goes all the way here, and we have 2i, and we have sine x cos x. So we have 2i is equals to sine x cos x minus cos x sinh x, and therefore I is equals to a half of sine x cos x minus cos x sinh x plus the integration constant. So our obvious integral, which was cos x plus sine x sinh x, being equal to the two integrals here, we found to be equal to a half sine x cos x plus cos x sinh x, and then we add the blue integral, which is a half sine x cos x minus cos x sinh x, and we see this and that would cancel. So eventually our problem becomes, let's revert back to cos x plus sine x sinh x equals to sine x cos x plus the integration constant. The halves add up to 1. So that is the that is the harder approach to it. Let's look at the simpler approach, right? So we have cos x plus sine x sinh x, and what happens here is that we do have, this is cosine x times the derivative of sinh x. Let me use the other approach so that I think this becomes easy for us. But this is the same as cos x times the derivative of sine x. Cosine x is derivative of sine x plus sine x times the derivative of cos x, right? And since we know that the derivative of uv is equals to v du plus u dv dx, so using the product rule, this integral here is the same as the integral of the derivative of the product of sine x and cos x, right? And since the integral is it's the antiderivative process, if you are differentiating a function and then you integrate, you've gone back and forward. So this becomes sine x times cos x plus c. And so within just a couple of minutes, you're able to have answered the question. So that kind of answers our problem. I would have taken the second route. It's easier and faster. But for those who want to use integration by parts and want to see how things kind of weave together, you could try and see this the harder part. For those of you who like torturing yourselves. Anyway, till next time, bye bye. That was it for today.